Hello. We still have some miscellaneous switching to talk about. And here we're going to talk about link aggregation bind or either channel or port channel. Those kind of terms are pretty much the same thing. So sometime for bandwidth or redundancy's sake, we have to bind many physical links into the one channel. So like here, for increasing the bandwidth or for increasing the redundancy, they bind these two into the logical one. So commonly we can bind 8 links or 16 links to be a group, and so just increase the bandwidth and redundancy. So that's what we call the ether channel. And from spanning tree perspective, a port channel or ether channel acts like a one link. So you don't need to worry about here. There's a link there. So MAC address learning and other functions for those kind of features also treat either channel as a logical link. So let's say let's look at the negotiation, some of the negotiation protocol around the port channel or either channel. When we want to create a port channel or either channel, we have some method. One of them is manually assign them, just to put them a switch on or manually put them on, then just the either channel or port channel will be created manually, and also have leverage the dynamic or negotiation protocol to create the one dynamically. LACP, the standard one, and also have like a PAGP for Cisco switches. So LACP has two modes, active and passive. So for like this, for channel, if one side is assigned as active, LCP active mode, the other side will be the passive mode, or also the active mode is okay. So for a specific ether channel, we have to at least one active for this protocol to work. So you just negotiate active one or negotiate with or initiate this communication with the passive one and just have some follow-up negotiation. So if we just finish learning almost all of the switching skills knowledge, and also we look at the switching port types. So if we want to configure a physical switches, we have to put the individual port into different types. Here I listed several commonly used types you can use. For example, it's a switch access port and the trunk port, and the port channel also divided into two, L2 per channel and L3 per channel. L2 per channel, L3 per channel, the difference in between is L3 is a bind port with multiple physical ports, but also you also give an IP on this interface, and And for layer 2, you just purely layer 2 switching port. So there's no any IP interface on IP addresses on this logical interface. We also have routed port or SVI port. SVI port means the SVI port is on behalf of a specific VLAN. For example, a virtual interface used for on behalf of a VLAN. So within this, with the PCs on this VLANs can configure this SVI port's IP address as a default gateway. So these are different types of physical port. So if we look at this to take a close look at them, so here we have 3 switches connected together. We also have 6 PCs. So for ports connected to the PCs, they are access port because you just put this physical port into a specific VLAN. So that's done. So we call this kind of interface or port an access port. And for example, this VLAN 20, you just put this fast Ethernet 0/18 to VLAN 20. So that's so we recall the access port. And for this port, we call it trunk port because as we learned, this is a lot physical channel with many different sub-channels, VLAN sub-channel inside of it. So we call it trunk type. Just a trunk allows many different VLANs traffic to go through. So if we add one link and to bound these two physically into the port channel, so we're using the L2 port channel. And yeah, this is some typical port types we're using. When it comes to switching topology or different port types within or on the NSX, so we can see that we leverage different terminologies for the similar function. For example, we always use port group to indicate there's a VLAN. For example, here there's a BDS 01 logical switch, and on this switch we create different PGs, just like creating different VLANs. So PG is equivalent to a VLAN. So this one can talk to this one because they reside on the same PG without using the router. And we also have some NSS specific terms like segment. Segment means there are 2 different segments. One is VLAN backed segment is equivalent to vSphere PG. So VLAN back segment does have to have a VLAN ID. to be associated. And another type of segment is overlay segment, overlay segment. So for the connection, if you can see that the ESS host or compute transport have some physical connection with switches. So we all assign this for physical link as trunk and allow some potpourri VLANs to go through. We don't need to have to use port channel like this because ESSi host or NSSi just leverage its own load balancing mechanism to distribute the traffic, so you don't have to use a port channel for distribution of your traffic. So that's it.